Okay, in these videos we're going to do a bit of practice at solving problems with multi-stage amplifiers. So our first example is from 4.68 in the Neaman Microelectronics textbook. Here we see a two-stage amplifier, and we're going to skip the portion of the problem where we solve for the absolute values of R1 and R2 and focus on finding the gain and the DC operating points. So the problem tells us that the DC voltage at the source of M1 needs to be 0.6 volts. And it tells us that the drain to source voltage of that transistor needs to be 2 volts, meaning that the drain voltage needs to be 2.6 volts. From this, we can then find the value for RD1 by writing a KVL expression. It also tells us that it wants ID Q1 to be 0.2 milliamps. This means that RD1 is equal to 12 kiloohms. For the second stage, we are going to have to use the current equation for MOSFET M2 when it's in saturation. Here we can estimate that the overdrive voltage is equal to square root of ID divided by Kp2. So VOV is equal to 0.707 volts. And for a PMOS device, we know that VOV is equal to VSG minus the absolute value of VTHP. So we can say that VSG is equal to 1.3 volts. I'm going to drop the 0.007 for convenience. All right, well, we already know the gate voltage because that's coming from the drain of the prior stage. So we can now tell what the source voltage is. All right, with this, we can find a value for RS2. So it's simply the voltage drop across RS2 divided by the current going through it. This should be equal to 2.2 kiloohms. Now, next, we note that the problem asks for the source to drain voltage to be 3 volts. This means that the drain voltage has to be equal to 0.9 volts. And we can now find the value for RD2. (1.8 kiloohms). Okay, now that we know the values of all of the resistors that are tied to the sources and drains of the circuits, we can find the voltage gain. We have an input on the gate of M1, and the output is on the drain of M1. And for the second stage, the input's on the gate of M2, and the output's on the drain of M2. So this is a cascade of a common source amplifier with a common source amplifier. Now we have a couple of capacitors that we need to be careful to observe. So here we note that CS1 is going to short the source of M1 to ground for the AC analysis, and CS2 is going to short the source of M2 to ground for the AC analysis. Now, the problem also notes that lambda 1 and lambda 2 are equal to 0. This means that the small signal output resistances, R sub 0, are equal to infinity. And we also note that because we're dealing with MOS devices and the voltage source of the input doesn't have any series resistance, that we don't have to worry about any voltage divisions at the input. So we can write our voltage gain expression pretty quickly. The voltage gain for this amplifier is going to be the voltage gain for the common source stage 1, which will be GM1 times RD1. This is inverting, so we need a negative sign. This whole quantity is going to be multiplied by the gain of the second stage, GM2 times RD2. All right, so quickly we need to find GM. So we can find GM1 as the square root of 2 ID times KN1, or 0.28 millisiemens. We can do something similar for GM2. GM2 is equal to 2 ID over VOV, or 0.77 millisiemens. We could have also used the current and the K value for that one as well, but we had a different piece of information. So with that, we can tell what the total voltage gain is. So we have the gain of the first stage is 3.36 volts per volt. The gain of the second stage is 1.386 volts per volt. The total gain is the product of those two, or 4.66 volts per volt. Now, I note that in a couple of instances, I've carried out answers to extreme precision. In general, we would round to the correct significant digit. I would probably say that the voltage gain here is about 4.7 volts per volt. Now, we note that both stages are common source stages, which are both inverting. So the product of two inverting amplifiers is a non-inverting amplifier, which is why the total gain is non-inverting. And that's our first example. Let's try another one in the next video.